In reach A and reach B, in reach A discharge is given as 4.7 meter cube per second and width is given as 4.8 meters, from which small q will be equal to 7.4 by 4.8, which is equal to 1.542 meter cube per second per meter. Let us find yc, that is critical depth q square by g whole power 1 by 3 in a rectangular channel, that is equal to 1.542 square by g is 9.81 whole power 1 by 3, which will be equal to 0.6235 meters. Capital Q is area into velocity, which is given as area is b into y naught into velocity by Manning's formula 1 by n r power 2 by 3. R is a by p, that is b into y naught by perimeter is 2 b plus 2 into y naught whole power 2 by 3 into s naught to the power of 1 by 2. Substituting q is 7.4, which is equal to b is 4.8 into normal depth, say y naught by n is 0.015 into b is 4.8 y naught by 4.8 plus 2 into y naught whole power 2 by 3. Bed slope is given as 0.0005 whole power 1 by 2, from which y naught will be obtained as 1.2 meters. Y naught is greater than yc, so the slope will be mild slope. In reach B, discharge is given as 5 meter cube per second and width is given as 4.8 meters. Since the discharge is changing, critical depth also changes, that is 5 by 4.8 whole square is small q by 9.81 whole power 1 by 3, which will be equal to 0.48 meters. And similarly, in the same way, q equal to area into velocity, we can find normal depth y naught, which is obtained as 0.918 meters. Since y naught is greater than yc, this is also mild slope, but y naught in the A case or A reach is greater than y naught in the B reach. So y naught at A is milder slope, A is milder slope and B is mild slope. So let us draw that. This is a milder slope and a mild slope. Critical depth at reach A is 0.623 and normal depth is at 1.2 meters, whereas in reach B, say this is A and this is B, critical depth is indicated by dotted line and normal depth by green thick line. Critical depth is at 0.48 meters and normal depth is at 0.918 meters. Here is the control point. Since it is y is greater than yc, it is a subcritical flow in which control point will be on the downstream side. So downstream and control point and the profile formed will be a M2 profile on the milder slope. Whereas if a sluice gate is introduced on the upstream side, a M1 profile will form, while on the downstream side of the sluice gate, a Vino contractor where control point is at Vino contractor, and here it is changing from supercritical to subcritical, so hydraulic jump and then followed by a M2 profile.